Hello everyone. Welcome to a new video of inorganic chemistry. Today we will start the next topic of inorganic chemistry, that is inorganic spectroscopy. What is spectroscopy? That we have learned earlier in our BSc days. But today we will learn from the beginning to our next step. So today is the orientation class of inorganic chemistry. This class will help you that how we will go in this chapter in future. So what is our strategy to know this chapter and to memorize this chapter and to learn about this chapter, because it is the heart of every chemistry, in every aspects of chemistry, in physical chemistry, in inorganic chemistry, in organic chemistry. So spectroscopy is a common topic and technique, because nowadays without spectroscopy any research, anyone can't think about their research. So spectroscopy, according to the exam purpose and also to the according to your next future term, the spectroscopy is the most important thing which you have to learn in from basic to from to the very high level of uh, research. Okay, so spectroscopy is a unavoidable tool for chemist nowadays. Okay, so now we'll start spectroscopy. So if we write spectroscopy, then what the thing that should come to our mind first? Spectroscopy. Spectroscopy is nothing but the interaction of interaction of electromagnetic radiation, electromagnetic radiation with matter. Okay, electromagnetic radiation with matter. Interaction of electromagnetic radiation with matter. So first term we have used in this chapter, that is electromagnetic radiation. What are the electromagnetic radiation? Let's consider a light. Light is a electromagnetic radiation. Okay. Now we consider only visible light. If a source of light, when we talk about light, the first thing that came to our mind is the sun. Sun is a light source. Okay. So this must be in yellow. So sun is a light source. So this is a sun. Okay. So as this is a sun, so this is a light source. Okay. This is a light source. So when we are talking about light in this time, what we have to know about it? We have to know what is the wavelength of light. Because in our 11 12 days, we have learned about that the light has a wave nature. It also has a particle nature, but it has a wave nature also. That is called electromagnetic radiation, is also known as electromagnetic wave. Okay, so this is a wave nature. This is a positive, this is negative. Okay, this is a complete wave. Okay, so when we are going to analyze this light, so the light is not monochromatic. Okay, so light will go in different direction. Okay, in different direction. So as light vibrate or oscillate in different direction, we want to have a slit, like this is called monochromator. Okay, monochromator. So this thing in spectroscopy you have to know in detail. Okay, so this is a monochromator. So when this with this through this monochromator, when light will pass, it will become a single wavelength light, or this is called monochromatic light. Monochromatic light. And this monochromatic light has a particular wavelength. Okay, there is a particular wavelength. What is the wavelength? So this, from this point to this point, this is the wavelength. What it is called? It is called lambda. Okay, lambda is the wavelength. Wavelength. Okay, this is wavelength. So the light which have wavelength, it has some energy. So if we're talking about the energy of light, why we are talking about the energy, we will discuss it later. When we are talking about the energy, so according to the equation, we know E equals to h nu. So the energy of light is directly proportional to what is h? H is Planck's constant. Planck's constant. Okay. And nu is wave number or frequency. Wave number or frequency. Okay. So we know nu equals to c by lambda. That is h equals to c by lambda. So from this equation, we can conclude that E equals to E directly proportional to 1 by lambda. Okay. E directly proportional to 1 by lambda. So from that, what we can infer from that? We can infer from that as the wavelength of light increases, the energy of light decreases. Okay. So there is a particular thing which we we have read, that energy and wavelength. So why we are talking about this energy and wavelength, and why we are talking about this electromagnetic wave when we are talking about spectroscopy? Okay, so this we have to know. So there is, if in electromagnetic in spectroscopy, what is happening general term, if a matter is there, okay, if a matter is there and this matter, a electromagnetic wave is there, some electromagnetic wave is hitting this matter, and after that what is happening, so from this electromagnetic wave, some electromagnetic wave will go out. So the spectroscopy is the analysis of this electromagnetic wave. So what electromagnetic wave will come, what is the wavelength or what is the frequency of that, and what wavelength or what frequency it is out from this matter. So why we are talking about its energy, because there is a change in nu or lambda. So that's why we are talking about the electromagnetic wavelength. So what is happening here, generally there is two state in any spectroscopy. This state